Hi, welcome again. So today our question is about statics. So let's solve these beams. Find the support, shear force, and bending moment. At A we have ruler supports, and at B we have fin support. So we have to find first the force reactions, and then we will draw our shear force and then moments. So we have here A, B, C, D, the force magnitudes, all of them is in A, B, C, D. So our student number here is 21, 14, 70, 87, which is we take this last six digits. So A is 1, B is 4, C and D and E and F. So I draw this pre-body diagram, which is we have ruler support but it in 30-degree from the y-axis. So we have X and y. Here we have fan support, so we have two unknown, and also we have moment pegs, which is AEF, so it's like become 187. And here we have CD, so which is 70, and here we have 4 kilonewton per meter, but I multiplied by with distance, so it's become rectangular, divided by 2, it's triangular, so it's 5 kilonewton. It is a point load, but where will be located? So here distance divided by 3, it will be located from 0.83 meter. So now just find the support. So we have now three supports, but this one's have two components, so it's like become four. We can't find here just by applying f of x or f of y, so just take a moment at each point. So the two supports will be become zero, so we can find now then easily. Because of the third will be going from that point, so it will be also zero. If I can take the moment at a, so ay and ax will be zero because it's located here. Because of the formula, the moment formula is force multiplied by distance, so here we have no distance, so it will be like zero. The bx will be becomes zero because of bx force multiplied by there is no distance from the y-axis, so this will be also zero. So we just find easily py. Now take moment at a, so I can write here just like take moment at a and clockwise is or anti-clock is zero. Okay, just to mute this notification. Okay, now moment at a is zero and clockwise is positive. So now we can just draw this force to the a point. So 5 multiplied by distance, which is 0.75, and 583 will be 1.8 1.58. Okay, so now we can just multiply the other force as well, which is 70 from the y-axis, so it's also become positive because of it's going like clockwise. So 70 multiplied by 0.8, 0.8 is become from here, which is 4 divided by 5.8. So I'm taking historically multiply by distance, which is 2 meter and 2.5 meter and 0.75, totals becomes 5.25. And also we have by, which is in negative direction, so by multiplied by distance, total distance is 7, and also we have negative direction moment, which is 187. This is fixed, equal to 0, so by becomes 15.28. Okay, so this one is becomes 15.28, and now we can find ay, which is from the f of y equation. So upward is positive. Now we can take ay is positive, but here we have angle as well, so this is cos 30. This one is going up, this is positive. Negative 5, one is going downward. 70 is also going downward, so 70 multiplied by 0.8. Okay, its y-axis is 0.8 and x-axis is 0.6 because of 4 divided by 5 is and 3 divided by 5. So this one is also done, and here we have by is going up, which is 15.28, to it, and there is no other forces. This one is just moment, this is now force, so equal to 0. So ay becomes, this one solve this one and divide by cos 30, so it will become 52.79 kilonewton. Okay, now just find the f of x to the right. So ax, so we find ay, so the ay and x is same, just multiply with the angle. So we have 52.79 multiplied by sine of 30. Sine of 30 is means like ax, and now we have x forces in 70, which is also negative direction, so 70 multiplied by 0.6, and we have positive bx equal to 0. So bx becomes 15.64, okay, kilo newton. So now I can show you here how to find, how to like sure that I find these supports is correct or not. So we here find three supports. If you can see here, this is the by, this is the ay, and this is the bx. So what is the ax? So ax is the same thing here, which is 52.79, but you can multiply with sine of 30. So this will be become the same things for x. If I can do here as well, so just draw here, ax will be become 52.79 multiplied by sine of 30. Okay, so this is easily you can find if it is a one supports but his components is two. Same here is we have 70, but this is two components, so we can find the x or the y is easily just multiply by find 8 and find 6. So now you can check your all support which is correct or not. So I applied a simple formula here. Let's see in the next page. So here you can see, let me explain you as well. uh, we have four supports, it's three supports, but the one have two components, so you can just add your all loads and add your all supports. If it is becomes 0 to minus from one of them, so your support is okay. Now we have 5 kilonewton downward and 70 is also downward, but it's two components, so you can take your two components, so all load is become 103. Okay, so this is 103 because of three loads, but now we have four supports, so you can ax is I multiply, because this is ay, sorry, so cos 30 is ay and sin 30 is sin, ay ax is sin. Okay, here we have two um, at a points, and also I have by and bx. If you can add this all, this is also 103, so your supports are okay. Then you can proceed your calculation. If you can get here, your support is okay. In the next steps, you can find your shear force diagram and bending moment diagram. So what you will do in the shear force and bending moment diagram, so you can solve this one's easily because this one is going up, so the shear force diagram will be start from the up, and then there is no load, so it will be like 0 degree, and then here will be a third degree because of it's like triangular course. But we can solve by proportionality method, so cut here and then cut here and then cut here, or anywhere between is these, so you can cut it three times, you can solve all the loads here. So let's see in the next video, because the video is going to be too long, so let's solve in the next video, you will see.